Just one quick thing today. This idea of arithmetic and geometric means. Now, you've seen means before, and you saw them in statistics. Right? It's another name for average, basically. There's actually a little bit more to it than that. Arithmetic mean, or as I say, what you're used to seeing is average. So we add all the numbers together and divide by the number of terms. Technically, an arithmetic mean is when you only have two terms. Because what it actually is used for, it's not average in statistics, although it is exactly the same thing. It's all to do with arithmetic series, where if you've got two terms and you want to find the term that would go in the middle, then it would be the arithmetic mean. So if I divided them by 2, or add them together and divided by 2, that would be a number that fits in the middle, and the common difference would be the same. However, whilst technically we're only talking about two terms, we can talk about n terms and expand it out. So if I wanted to find the arithmetic mean of n terms, I'd find the average, add them together, divide by n. Now, when that comes to talk about an actual sequence, it sort of loses meaning after two terms, because what are we actually saying? I've got n terms, I'm going to divide them by however many. I suppose, what am I doing? I'm finding the one that fits in the middle of the pattern, maybe, so like a median or something like that. So that's what arithmetic mean is, basically what you understand to be average. But that then makes more sense about what geometric mean is. It's exactly the same thing, but applied to a geometric sequence rather than an arithmetic sequence. So if I had two terms, and I want to find the one in the middle, well, what's the difference between arithmetic and geometric? Well, the difference is multiplying instead of dividing. So to find the geometric mean, I would multiply the two terms together, or if I expanded it out to n terms, I'd multiply the n terms together. Now, in the arithmetic mean, we divided it by n, okay? Because if you remember, arithmetic mean, we said n number of differences, or n minus 1 lots of differences. Now, in geometric, it was the ratio to the power of. And so the opposite of power of, if you like, is finding the roots. Opposite of squaring is the square root. Opposite of cubing is the cube root, and so on. So if I have n terms, I'll find the nth root. So back to our simple one where there's two terms, a geometric sequence, and I want to find the term that's in the middle, I'd multiply them together, find the square root of that answer, and that would end up giving me a term that's in the middle of the number pattern so that the ratio is the same and it fits the pattern. And the generalization of all that is multiply them all together and find the nth root of whatever that total is. So say our two numbers were 4 and 25, and I wanted to create, well, both an arithmetic one and a geometric. What would go in the middle? For an arithmetic one, well, the one in the middle would be 29 on 2. And that would be evenly spaced between 4 and 25. If it was a geometric pattern, however, then the middle term would become 10, because the common ratio now would be 10 divided by 4. So if I go 4 times 10 divided by 4, I'll get 10, obviously. If I go 10 times 10 divided by 4, I'll get 100 divided by 4, which is 25. So there's now a common ratio between those numbers. Okay, that's basically it. Ooh, there we go. So there's a handful of questions to have a go with that. So geometric mean, arithmetic mean.